this module, we're going to spend some time looking at exploratory analysis. Specifically, in Module 9.1, we're going to look at what is called the Nanier and the VisDat package, and both of them are going to help us visualize missingness in our data set. So you'll notice here I've got the Module 9.1 script open. And so the first thing that we have here is just a little bit of notes. So your book does not cover, I should say, VisDat and Nanier. So instead, I'm going to be using this as the source information, and I have a link here so you can follow this, and I'll also post this link in Canvas. And so this expert here is from that website. So whenever we have missingness, we need to make sure we carefully explore and handle it in the initial stages of our analysis. Now for this course, we're primarily focused on exploratory analysis and descriptive measures, not so much statistical methods in terms of inferential methods, and then also how to handle missing data. So I'm going to primarily just focus on how to know that you have missingness and just do some exploration with it. I'm not going to get into things like imputation and other ways to handle missingness. So for that, you would need to take another course that actually talks about statistical analysis. All right, so again, this comes from this website. So in the website, they describe the tools in the package for exploring missing data. That website will also go through some of the imputation. So if you're interested in that, you can read, further on in that website than what we're going to cover. So there are going to be 3 different packages you're going to want. And so make sure you load all of these. And just as a reminder, before running the library statement, you do have to make sure that these are installed. So you can run the install.packages command, or you can come up here to Tools, Install Packages, and install each of them. Right. So for the data set, we're actually going to pull the data set from another package in R. It's the VIM package. This is another package that deals some with missing data. So if you're interested in even more ways to visualize missing data, you can look into the VIM package, but we're just going to use the diabetes data set from it. All right, so here is that diabetes data set. We can read a little bit about the diabetes data set here. So you can see there's several different variables in this data set. So the first thing we might want to do is just make a couple general summaries of the data set, and we've seen some of these before. So first, I might just use the summary function. And so notice what the summary function does. It's just for each of those variables in the data set, it gives me the minimum, first quarter median mean, third quarter max, and then it also tells me the number of missing observations for each of the variables. And we can see in this data set there are quite a bit of missing observations. We've seen the structure function before, so this just gives me the structure of this particular data set. It is a data frame. We can see the different variables here, and then the first couple observations for each of them. We can also use the glimpse function, and the glimpse function is part of the dplyr package. And remember, the dplyr is included in tidyverse. That's one of those ones that we saw before. So what I've got here is just kind of a reminder, and we mentioned this earlier. Whenever we call a function in R, we could call it just by the function name. So I could just call glimpse and then give the name of my data set. Or you can use the full name. So glimpse is part of dplyr, so to call it by the full name, we could do dplyr : glimpse. Either way will work, but this is really useful when you've loaded a lot of packages and you're worried about masking. And we've talked about masking before. That's when you have 2 functions by the same name in different packages. So this way you can guarantee you get the one you want. So notice if we run this one, we get something similar to structure. Here we do get the number of rows, the number of columns, each of the variable names, and then again the first couple observations for each of those. So what we want to do is we want to visualize where the missing data is. And so the VisDat package provides a nice way to visualize missing data. And so it provides a visualization of an entire data frame all at once. And sorry, I paused there because I realized I have the word visualization spelled wrong a couple times. So let me fix that really quick. So again, these are going to visualize the whole data frame at once, and it's going to provide information about the class and the data input into R. So we're going to try the VisDat function first, and all I'm going to do is call VisDat and then put in the name of our data set. And so we get this nice visualization here. And you'll notice this is in the background made by ggplot. We can see it looks very similar to ggplot. So what we have here is each of our columns represent one of our variables, and over here on the left we have our observations in order. Here in our legend we have the different types. Remember, this is how the data is stored in R, so we could have a factor, an integer, or it could be numeric, and then if it's grayed out, that's going to be NA. So looking at outcome, it looks like outcome is included for all of the observations. For number of pregnancies, we're missing several. For insulin, we can see that there is a lot of missingness. Age looks to be complete. BMI, we've got some missingness, and diabetes pedigree function seems to be complete. So let's go back and match that with what we saw earlier when we were in that summary. So for pregnancy, we can see that there were 111 NAs. Seems reasonable based on what we have here. For outcome, we didn't have any NAs, and so that matches what we see here. Same thing with diabetes pedigree function, no NAs, and we can see that here. So again, really what this function is doing is it's giving us just a quick way to visualize which one of our variables has missing data, and then we can also compare and see things like glucose has very few, where again insulin has a lot of missingness. We can also use the vismiss function to do something similar, but vismiss is just going to pull out the missingness. So we get a similar plot to what we had before, but notice one thing, they are in a different order, so be careful. Outcome is at the end now. And here we just have gray and dark gray to denote present or missing. And the nice thing down here is we do get to see that 11% of the observations in this data set are missing. Now the other thing we might want to do is explore missingness relationships. So for example, let's look at a scatter plot of insulin as a function of skin thickness. And I'm not saying that biologically it makes sense to compare these. This is just more for illustration. So we could create a scatter plot using ggplot. And notice when we do this, ggplot gives me this warning that it removed 374 rows containing missing values. So by default, when a scatter plot is made, if either skin thickness or insulin is missing for an observation, so if either one of those are missing, then the whole row gets removed when you create the scatter plot. So you might want to add in something, and this is again during the exploratory analysis, to look at that missing data. So to do this, you can add in, instead of using geom_point, we can use geom_miss_point. Alright, so what this does is all of the blue are the not missing observations, and all of the blue ones are these exact same points. So the points that are normally there when you use the geom_point are now there in the blue. What has been added are these red points. Now remember, they were either missing in terms of skin thickness or they were missing for insulin. So we don't have actual measurements for one or both of those variables for these observations. So what this function does is it replaces the NA values with values 10% lower than the minimum value of whatever was found in the data set for that variable. So really what we're looking at here is just the placement on the plot of where these are. And what this tells me, what I can see, is anything down here in this piece, this was missing in both insulin and skin thickness. These right here, these had probably actual values for skin thickness, but did not have values for insulin. So what this tells me, and if I go back and look at my plots, I should see a lot more missingness for insulin than I do skin thickness. So going back to what we had, we do see there is a lot more missingness in insulin than there is in skin thickness. And it looks like if we look across here, everywhere that we're missing skin thickness, we're also missing insulin. But there are cases where we're missing insulin, but not skin thickness. And so that is supported by this plot here. Now, since this is created using ggplot, we can do all of the normal things that we did with ggplot that we saw earlier on. So for example, we might want to compare this scatter plot for the two different outcomes, which in this case are diabetes yes and diabetes no. And we can add the facet wrap to do that. And one of the benefits to this, if we're going to explore that missingness, I would be really concerned if in the yes diabetes, all of the missingness was occurring for the yeses, but none of it was occurring for the nos. But looking across here, just visually speaking, it appears that the missingness is similar between the yeses and the nos for diabetes. Now, another thing that you can do with ggplot, and we haven't talked about this before, but it's something you may be interested in, is you can also change what are called the themes or the overall look. So for example, we could add in theme dark, and you'll notice it makes it dark. So this is just nice, to make it look different ways. And there's lots of different themes. So I've included a link here if you want to visit that and look at some different themes. And there's actually a package that has themes. It's called GG Themes. So loading this one. Here's just another example of a theme. And so themes can get rid of those grids in the background if you want that, and different themes will have different text types. So look, you can see the text here is a little bit different than it was on the previous one. So those are just two visual things that I wanted to mention. There are other ways to visualize missingness. So another one that you could use is what's called the ggmiss var function. So if we run this one on the full data set, what this does is for each of the variables, it just draws a line with a point to the number that are missing for that variable. So just like we talked about, we saw that outcome, age, and diabetes pedigree function have 0 missing values, whereas insulin had quite a few. You can also use the facets here as well. So we could do this comparison between those with diabetes and those without, and we can see that the pattern of missingness is similar between the two. Again, an important thing. If I saw that the pattern of missingness between the two wasn't similar, then I would be worried that the missingness might be linked to one of the outcomes, and so that would be something I'd want to pick up in my exploratory analysis. And then the last thing, just like before up above, you could always add in themes here as well. So here's a different theme, just makes the plot look a little bit different. And so you can add tables, you can change the axes labels just like we've seen before. This is going to act very similar to any of the other ggplots that we have seen. So again, the purpose of this is just to add into your exploratory analysis just a couple ways that you can explore missingness. Always something that you're going to want to include in an exploratory analysis, because again, you would want to note, for example, if missingness, the pattern of it changed for different outcomes. You want to note if there are some variables that have a lot of missingness, whereas some don't. Again, all part of that exploratory analysis. So as always, if you have any questions, please let me know.